Have you at any point dissected whether we're genuinely alone in the universe, or accepting that there's more to our world than what we see? Imagine what's going on if the James Webb Telescope finally shows that we live inside a black hole. It could change everything as we learn more about this groundbreaking discovery, which will make you question all that you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi films, but they're truly terrifying. According to experts, black holes in space are thought to contain massive amounts of matter packed into an incredibly small region. Consider a star, typically larger than the Sun, all squeezed into a circle the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape it. Scientists have been fascinated by black holes for decades. They've studied objects in space that are so massive and dense they can trap light. The most well-known theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves behind a dense core. If the mass of this core is a few times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes isn't easy, as they don't emit light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls that matter toward it in a process called accretion. Additionally, when a regular star gets too close to a black hole, it can be destroyed, emitting X-rays in the process. Black holes also significantly affect their surroundings. They can consume nearby stars, emit powerful radiation, and even influence the formation of new stars in certain regions while slowing it down in others. But where do black holes come from? Imagine stars, once enormous and powerful, meeting their violent end in an extraordinary event known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that reach their cosmic end in a supernova explosion. Smaller stars, when they die, transform into neutron stars, extremely dense objects, but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. During this collapse, something strange happens near their surfaces. Time itself seems to slow down. From the perspective of an observer far away, time appears to freeze near the event horizon, the boundary beyond which nothing can escape a black hole. It's as if the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a much larger and more powerful black hole. Similarly, when a black hole interacts with a neutron star, they create a colossal phenomenon that defies understanding. Scientists have long grappled with the size of these cosmic enigmas. Black holes come in two main sizes: small and large. However, small is a relative term. Stellar black holes, formed from giant stars, can be as large as 10 to 20 times the size of the Sun. In the Milky Way alone, there could be 10 million to a billion of these black holes. But there's something even more massive: supermassive black holes. These exist at the centers of galaxies, including our own Milky Way. They are millions, if not billions, of times larger than the Sun. It's like a vast, dead space pulling everything toward it. Renowned physicist Stephen Hawking studied black holes throughout his life. His theories were always intriguing, though some couldn't be confirmed due to a lack of advanced technology. But hope is on the horizon. A single scientific instrument is making a massive impact: the James Webb Space Telescope, JWST. The JWST is no ordinary telescope. It's an engineering marvel and a testament to human ingenuity. While previous space telescopes like the Hubble have done exceptional work, the JWST is a powerhouse. Its $10 billion price tag reflects its groundbreaking capabilities. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this extraordinary project to life, with contributions from over 300 universities. Despite the risks of such an ambitious project, the JWST is venturing into uncharted territory, pushing the boundaries of our knowledge and taking us to places we've only dreamed of. After its successful launch, NASA announced that the telescope has enough fuel to last more than twice its initial mission lifespan. Since its launch, the JWST has achieved remarkable milestones. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sunshield and giant primary mirror, both of which had to be folded to fit inside the launch vehicle. One of the most exciting moments came when NASA announced that the JWST had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots from the star's light, captured by the 18 mirror segments on the primary mirror. NASA later released another stunning image of HD 8446, where the 18 unfocused copies of the star were combined into a deliberate hexagonal arrangement. Once the observatory successfully adjusted its instruments, the James Webb Space Telescope began its primary mission, to reveal the mysteries of the universe. Its unmatched capabilities allow it to peer farther into the cosmos than any telescope ever has, offering us a glimpse of the universe's infancy, shortly after the Big Bang. Unlike the Hubble Space Telescope, which primarily observes visible and ultraviolet light, the JWST is optimized for infrared light. This is crucial because infrared wavelengths can penetrate dust and gas clouds, revealing regions of space previously hidden from view. With this tool, astronomers hope to study the formation of the first galaxies, stars, and planetary systems, as well as uncover the secrets of black holes. One of its key missions is to investigate exoplanets, worlds beyond our solar system. The JWST is equipped with advanced instruments capable of analyzing the atmospheres of distant planets, potentially identifying signs of life or conditions that might support it. Imagine the implications of finding another Earth-like planet in the vastness of space. But the JWST isn't just about exploring the distant universe. It's also teaching us more about our own cosmic neighborhood. It can study planets and moons in our solar system in unparalleled detail, helping us better understand their composition, climate, and history. The telescope's deployment marked the beginning of a new era in astronomy. Already, the data it has sent back is reshaping our understanding of the cosmos. For instance, it has captured breathtaking images of distant galaxies and nebulae, each a masterpiece of cosmic artistry. These images aren't just visually stunning. They contain a wealth of scientific information that could take decades to fully analyze. Perhaps the most exciting aspect of the JWST is its potential to confirm or challenge long-standing scientific theories. For example, its observations of black holes might help answer questions about their formation, evolution, and role in shaping the universe. Could they be gateways to other dimensions? Do they hold clues about the nature of time and space? The telescope might even provide evidence that reshapes our understanding of the very fabric of reality. If we discover that we exist within a black hole, or some other mind-bending cosmic structure, it would revolutionize our perception of the universe and our place in it. As humanity gazes into the depths of space with the JWST, we are reminded of the profound questions that drive us to explore. Are we alone? How did the universe begin? What lies beyond the boundaries of what we can see and understand? The answers may not come easily or quickly, but the James Webb Space Telescope represents a giant leap forward in our quest to unravel the universe's mysteries. With its unmatched technology and the combined efforts of brilliant minds worldwide, it promises to be one of humanity's greatest scientific achievements. The journey has only just begun, and the possibilities are as infinite as the cosmos itself. Portions of the essential mirror will start the most common way of stacking pictures, mixing 18 pictures into one clear view, thanks to its cutting-edge innovation. The JWST will assist specialists with concentrating on the beginning phases of the universe after the Big Bang. It will zero in on what occurred after the first stars formed, in a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, made to have an electric charge again by radiation from these first stars. This includes thinking back billions of years, which is only possible with a strong telescope like the JWST. The telescope will also support finding exoplanets, which are extremely difficult to recognize because of how they interact with their host stars. Its strong sensors will be able to detect these planets in more detail, sometimes even imaging their atmospheres. Understanding the conditions and states of these planets could assist researchers in predicting whether certain planets are habitable, as well as concentrating on the development of planets. Scientists are studying these worlds to understand how matter is organized on a large scale. This, in turn, helps us recognize how the universe developed and how the twisting and bending galaxies we see today formed from various shapes over billions of years. One of the JWST's objectives is to look back at the earliest galaxies to better understand that development. Researchers are also trying to understand how we got the range of galaxies that are visible today and how galaxies continue to form and evolve. But most importantly, the James Webb Space Telescope will help us answer the biggest questions of all. Are we alone in the universe? And are we residing inside a black hole? The JWST has already been on the hunt, and guess what it found? Builds called polycyclic aromatic hydrocarbons, PAHs, hiding around those immense, extremely massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are the goth kids of the universe. They're everywhere, from distant galaxies to comets and even in our own solar system. Now, they're not just fascinating because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is often a sign that there are some warm, young stars nearby. But wait for the twist. A curious astrophysicist, Ismael Garcia Bernard from Oxford College, decided to study 3 active galaxies known as NGC 6552, NGC 7031, and the famous Stephan's Quintet, found millions of light-years away in the depths of space. What Garcia Bernard discovered will make your hair stand on end. In the central regions where the black holes dominate, he found a lot of PAHs. Sounds fascinating, right? Well, here's where it gets chilling. The radiation near those massive black holes curved the PAHs, essentially transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into the deep darkness. Imagine being consumed by the darkness itself. But wait, there's a glimmer of hope. Or maybe not. The real question here isn't whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? Everything seems to align with a theory that maybe we're living inside a black hole, or more specifically, inside the event horizon, the boundary between the universe we know and the unknown. Could it be that everything is connected inside a black hole? The James Webb Space Telescope is out there right now, searching for answers to the unknown. Stay tuned, and maybe it will make us all reconsider what we thought we knew about existence. Reality might be much more tangled than we understand. In the fascinating world of cosmology, few topics have generated as much interest and mystery as black holes. These monstrous objects, with their ability to twist space-time and consume everything in their vicinity, have long been the subject of both scientific study and popular imagination. The claim that we have finally discovered what's inside a black hole, made by renowned physicist Michio Kaku, plays on the wonder and curiosity surrounding these enigmatic objects. But what does this bold statement mean? Has science finally unlocked the mysteries of what lies inside the event horizon of a black hole? To understand Kaku's statement, we need to take a step back and examine the concept of black holes, the current state of research, and the significance of the latest discoveries in the field. A black hole is a region in space where the gravitational pull is so strong that not even light can escape it. This phenomenon is the result of a massive star collapsing under its own gravity after it has exhausted its nuclear fuel. When this happens, the star's core contracts, and if the mass is great enough, it forms a singularity, a point of infinite density where the laws of physics, as we know them, break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape, not even light. For years, the existence of black holes was purely theoretical. The concept first arose from Albert Einstein's general theory of relativity. However, it wasn't until the 1960s and 1970s that scientists like John Wheeler, Roger Penrose, and Stephen Hawking began to develop the mathematical framework that would bring black holes into the realm of accepted science. Despite this theoretical understanding, black holes remained a subject of mystery and speculation. What happens beyond the event horizon? Is it possible to peer inside a black hole, or is it forever out of reach? The event horizon of a black hole marks a point of no return. Once something crosses this boundary, it is inevitably drawn toward the singularity at the center of the black hole, where it is crushed to infinite density. Despite their importance in the black hole model, the event horizon is not something we can directly observe. The very nature of a black hole means that light cannot escape its gravitational pull, making the study of what lies beyond the event horizon extremely challenging. For many years, black holes were considered to be eternal prisons, where information about the objects falling into them would be lost forever. This idea was encapsulated by the so-called information paradox, which arose from the work of Stephen Hawking in the 1970s. Hawking suggested that black holes could slowly dissipate due to a process known as Hawking radiation, a quantum phenomenon that proposes black holes gradually lose mass over time. If this radiation carried away all the information about what had fallen into the black hole, it would violate a key principle of quantum mechanics known as unitarity, which states that information must be preserved. This paradox sparked decades of debate among scientists.